Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 8G. My name is Alesha Mullah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, in Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Thailand, and the virtual event is being held from the 9th to 11th April via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes to present and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chairs for today's session. Our first chair for today is Dr. Banisha Bora. She is an assistant professor at the Assam Royal Global University, India. Her research interests are nonlinear behavior of structures, earthquake-resistant design of structures, retrofitting of structures, vernacular houses and earthquake damage surveys. She is actively involved in teaching, research, and academic development in modern computing domains. Good morning, ma'am. We would like to request you to please say a few words.
Thank you, Alyssa, for a nice introduction. Dr. Bonnie Sabora, it's a pleasure to serve as session chair for the virtual room 8G at the 11th International Conference on ICTIS. This session features a range of insightful presentations in the areas of AI, IoT, and smart systems addressing important real-world challenges. I encourage everyone to actively participate and engage in the discussions. With this, I request Dr. Hiramjyoti Hazarika to kindly continue with this.
All right. Thank you, ma'am. We'll introduce her. So our second session chair for today is Dr. Hirakchati Hazarika, who is an assistant professor, HOD, and assistant dean of academic affairs at the Assam Royal Global University, Guwahati, India. His research interests include library automation, digital information systems, open source software implementation, bibliometrics, and the application of artificial intelligence in information science. He is actively involved in teaching, academic leadership, research, and curriculum development in modern research computing domains. Good morning, sir. We request you to please say a few words.
Yeah, thank you so much, Alicia, for nice introduction. It's my great pleasure to welcome you to this technical session organized by GR Foundation and in collaboration with GR Scholar. It's a virtual session. I am honored to serve as the session chair for this session alongside my co-chair, and I extend my sincere gratitude to the organizing committee for this opportunity. I would also like to request to all the present kindly adhere to the allotted time for their presentation to ensure a smooth and efficient flow of the session. Thank you. Over to Alisa.
Thank you, sir. Without further ado, we'll begin with the presentations for today. Our first presentation is by Sridharan Ji, who will be presenting an intelligent IoT and AI-based irrigation system for efficient water management in hilly agricultural area. You may now begin your presentation.
Hi, ma'am. Am I audible?
Yes, you are.
Ma'am, good morning, ma'am. Today I am presenting project on AI-based smart irrigation system for hilly regions. This project focus specifically for the hilly regions people because the current existing system where these products are in flat surfaced regions and they cannot measure how much rain is in the terrain.
Please share your screen.
Yes, ma'am.
Dear presenter, please make it full screen.
Sriza, I think you might have disabled your mic input for your device. You just try turning that on.
Yeah, I think we can go to next presenter if he has a problem with the audio or any other kinds of problem.
All right, in that case, we'll circle back.
Okay.
Our next presentation for today will be by Anirudh P, who will be presenting analysis and evaluation of static noise margin in SRAM cells with multiple defects. You may now begin your presentation. Is Anirudh or any of his co-authors present in the meeting? All right, in that case, we move on to the next presentation. Our next presentation will be by Sunil Jagannath Panchal, who will be presenting catchfish optimization algorithm-based efficient net V2M for anomaly detection in sustainable industrial IoT. Sunil, you may now begin.
Hi everyone, myself Sunil Jagannath Panchal. Today I'm going to present my paper on the topic of catchfish optimization algorithm based efficient net V2M for anomaly detection in sustainable industrial IoT. It is the completely related to industry where most of the sensor generate massive data and how to catch its anomalies. So here are the contents, objective, research gaps, principle, and so on. So here my objective, here our objective of this paper is in industrial scenario, there are thousands of sensors are integrated at a time and they generate massive data as well as their high or low alarm system has been developed over there. So here to analyze the alarm signals and catch the actual alarm to focus on the predictive maintenance, this system has been developed. So here, these are the objective. IoT system generate large amount of high dimensional data. So as well as reliable anomaly detection is critical for these systems and security efficiency. Right now, we hear that most of the industries are hacked by the ransomwares. So most of the problem is here about the security. So it's a industrial security. So here again the problem statement is in traditional methods like LTSTM, STM, and the DRL. So these methods struggle very high noise in noise of data in the dynamic environment. So which reduces its detection accuracy and system reliability. And thereby system becomes very slow and noisy. So here, the proposed solution is an optimized DL-based anomaly detection framework is proposed by using Shapley Shapley additive explanations and the efficient net V2M version 2 medium algorithm as well as catchfish optimization technique. So here by doing this we can we achieved the accuracy of 95.3% of the recall, 96.6% of recall, and precision is the 95.2%. F1 score is 95.9%. So it demonstrates a strong and reliable detection performance by using these methodologies. So here are the some research gap which we have captured in long short-term memory and bidirectional long short-term memory GRU method. It gives a strong performance, but it limited optimization and strategies. Optimization is not clear, as well as it works with the very small data sets. But if the system is sensors are or system industrial system is generating huge data, so this algorithm becomes very slow. And another one is DBGCN. That's a distributed bias collaborative generative assertive network. So it improves accuracy, but weak in handling imbalances, because in some of the systems, for example, there are the various thresholds are set for the different sensor as per the process environment for the alarm system. For example, if for the temperature 80 degrees 80 degrees centigrade is set, and for the some pressure only 12 psi is set. So this time the comparison becomes imbalanced, and this algorithm becomes confused. So this model is also shows the limitation. Next is the DRL. It reduces the training time effectively, but it lacks the distributed IoT architecture support, because the signal is coming from the various places of the plant. Next is LSTM. Excuse me, can I mute my phone?
Okay.
Sorry. So it shows the good performance, but poor generalizability, limited adaptability across the various types of data sets. So here, proposed model is cache-based optimization algorithm-based efficient net V2M for anomaly detection, as well as it improves the conversion speed and detection accuracy. Why CFO-based efficient net version 2 medium for the anomaly detection? So here, this is it uses the heuristic and the heuristic approach, and it's the nature-based algorithm based on the fishing strategy by the fishermen, as well as it gives the very performance evaluation on the accuracy, precision, recall, and F1 score. Here we have used the data set. It's SCAP version 0.9. It is publicly available data set. So it's for the simulation purpose we have used. So here we have used around 46,861 samples. Out of that, we have filtered 45,847 samples. So here, this is the data set. This is the input for the data set, and from this we have cleared the data and its min max normalizations in the pre-processing phase, and we have chosen 7 data of the different sensor simulation values. So here, this is the explanatory data analysis for this one. We have chosen 33,000 for the majority class, and out of which 13,241 for the minority class. So here 33,619 are for the normal, and out of which this for the alarm generation for the various abnormalities in the process signals. So here, this is the proposed methodology. It's a framework. So in the first block, IoT data, it captures the data from the various type of sensor installed in the field. in the plant area from the various machineries, and its signal is given to the for the pre-processing data cleaning. So where its noise mean max normalization is done and it sets to the proper value, and whatever be the garbage value it generates, it's skipped. And here this the shape algorithm given is here. It reduces its dimension, high dimension data to the lower one, and its signal is given to the efficient net V2M algorithm, where it captures only high critical alarms which will cause the plant shutdown, and it will given to the cache piece or optimization algorithm. Here it enhances the training speed of the model. So here I'm directly going on the algorithm.
I'm sorry, excuse me. You have about
Yeah.
1 minute left.
Wow. Okay. So here, this on the how this algorithm works. So as the fisherman goes on the field for the fishing, as per his experience, he finds some of the areas where he can find the fish. So he use his discretion and work over there. But for the collective fishing, so it requires its experience, and it explore to the global search. So here, these are the various phases and iterations, how this algorithm works. So it in initialization, random generation of search agents like a fisherman. So it generates the fitness function, which evaluates the solution using classification accuracy. It captures only those critical alarms which are prone to plant shutdown. So after, and it's also works on the exploration and exploitation strategy, where in exploration phase it searches the global search for the optimal solution, and from this optimal solution it picks the exact solution which will be useful. And in independent search, random search using the disturbance strategy, like a fisherman, when he wants to fish, so he first make the turbulence in the water and gather the fishes at the one place. So this strategy works here. According as per this, it categorizes the various alarms and anomalies in the from the sensor data, and it classifies it into the different groups. In the group capture, collaborative search groups, as well as in exploitation phase, it refines the best solution locally and gives the solution to the output model. In termination phase, it stops when optimal solution is reached. And here, in the safe explainability model, so it reduces the dimensionality as well as noise of the various signals which the model has chosen. So here, if you see, it is in the two phases. From the right side, apart from 0, so this is the fitness function, and this is in the left side, it discards the signals. It completely works on the game theory as a game gives the prediction and the user is the inputs. So from here, it captures only it classifies and filter only some adverse signals from various sensors from the thermocouple
Yes, Sunil,
yeah.
please summarize your presentation.
Okay, sir. Thank you. here, if you go for the comparative analysis of the different algorithms, so here, this one of the algorithm we have developed. Here is the dashboard for this. So we put the how much % of the efficiency we want and to train the model. So I already have given its execute its value because it's just its execution is just time consuming. So that's why after execution of the 80%, so accuracy, precision, recall, and F1 square for score for the different techniques have been tabulated here in the model. And after running of this result has been developed, has been generated of the performance matrix. So it's here. In accuracy, if 90% of data, CFO efficient net with VM, it generates the 0.953%. It's the highest accuracy as compared to the traditional models. If we go for the precision 80% of data, it generates 9.37, its best precision, and it generates the pure false positive rates, and it generates the true positive rates. As well as if we go for number one this, so its highest recall detects more anomalies. And
I'm so sorry to interrupt, sir, but your time is up and we have others in the queue, so we'll have to wrap up the presentation.
Okay.
If any of the chairs have any questions to ask, we can have
Yeah,
those.
any question, please?
Mr. Sunil, that was a nice presentation. I have few suggestions. When you present something, always provide slide numbers. And you have given one data set. So provide references for that data set.
Yeah, you already have provided in the paper.
Okay, but in PPT also, you have to mention the reference.
Yeah.
And in figure 1, you have shown the parameters you have considered for the study. Go to figure 1. I don't have the slide number, that's why I'm saying go to figure 1. I have seen one figure 1. So the next figure, not this one, where you have shown your parameters for your study.
No,
Not this one.
These are not the parameters. These are
no. After this, I think you have shown the parameters.
Okay.
Go to the next slide. Just tell me what are the parameters you have considered. What are the input parameters?
Input parameters are pressure, speed.
So you have shown one figure for that.
Okay. Input to the IoT data.
Yes.
Yeah.
So what are the limitations? Have you considered all the probable parameters according to you?
Yeah. For the parameters, we can increase number of parameters to this model. Right now.
So what have you not considered here?
Yeah. Right now is in the simulation phase, but I'm working on to implement it in the practical one. So I'm working on one of the controller, NVIDIA Jetson Nano. So I'm developing one of the model for that.
And go to the last slide, output conclusion slide. Here. Okay. So no. Before this. So here you have shown different data sets like 90%, 80%. So are there any outliners from the data? Why you have considered only 90% or 80% for this?
This one. It has been generated from the source, from the algorithm, and this we have developed. So here, for the training data, 60%, 70%, 80%, 90%.
Okay, why?
Yeah, it's right now in the under development phase right now. So I'm developing it and refining it up to 100%.
Okay, thank you.
Yeah.
If anyone have any more questions, then you can ask.
So, hello, Sunil.
Yeah.
This is Dr. Hirok. Is this your PhD area or something others?
Yeah, I'm working. My PhD area is industry 5.0. So
Okay.
here I'm integrating IoT, edge computing to the all the IoT considering edge computing and the blockchain technology.
Okay. How you are going to incorporate blockchain in your study?
So in blockchain, I'm going to integrate the supply chain management uh, operations over there.
Okay. Okay. So, I think we can warm up here. So
Yeah.
over to next presentation. Nice to
As well,
talking with you.
yeah.
All right. We'll move on
Thank
to
you
the
very
next
much.
presentation now. So next we have Hileni Ihambo, who will be presenting evaluation and demonstration of the organizational security culture framework for a Namibian public enterprise. Hileni, you may now begin.
Am I audible? Good morning.
Yes, you're audible.
Okay, can you view my screen?
Yes, we can.
All right. Hi, good morning. My name is Hileni Ihambo from the Namibian University of Science and Technology. I'm going to present my paper on the evaluation and demonstration of the organizational security culture framework for a specified public enterprise. Okay, so Namibia, like many developing nations, is experiencing a rapidly escalating cybersecurity crisis. It's mostly not rooted in technology, but in people and culture. So the motivation is 73.9 million cyber attacks were reported from FNB in 2025 in Namibia. 626 gigabytes of data was exfiltrated from telecommunications through a ransomware attack in 2024. 500 gigabyte was also exfiltrated from a Namibian airport company. This recently happened in Namibia. And 7,000 PII data was publicly exposed by NASFAF in 2015. So the institutional gaps that were identified is that there's no formal cybersecurity legislation in Namibia. And the rest of these identified gaps, I'll get into them in the next slide. Okay, so to address the problem, I adopted the design science research methodology, which is the DSRM, as proposed by the PEFAS and colleagues in 2007. This is a 6-stage iterative methodology well suited to the development and evaluation of the security culture. So the first stage is the problem identification stage, which is grounded in baseline surveys, interviews, and policy audits. The second stage is the defining of objectives, which is the framework, goals, and design criteria. Then the third stage is the design and development. This one speaks to the 5 core hard components of the framework. The fourth one is the demonstration, which we are going to go into details. The demonstration, which is a 4-phase pilot at the PE. So I'll call the institution, the pilot institution PE. And then the evaluation, which we're also going to go into, is we used a dual approach where we used the expert panel and KPI measurements. And at the end, communication was done for this thesis and paper. So at the heart of the research, in the is the organizational security culture framework. It comprises of the 5 interrelated components, so each addressing a distinct but connected dimension in the security culture. To start with, the first component is the risk assessment component, which is identifying threats and vulnerabilities using the NISP-SP framework, as specified on my slides. Moving forward, the second component is the security policy and enforcement, which is formalizing rules and technical controls aligned with the ISO standard as specified. The third component is security compliance. This one speaks more into builds around audit mechanisms and automated monitoring to ensure policy is not just written, but actually followed. The fourth one is the most important one, the training and awareness, the most critical one, drawing at the NISP-SP, 800. This component emphasizes role-specific continuous learning. And then the third one is the ethical conduct, which shifts cultural assumptions. So there are 8 inter-component relationships that create a mutually reinforcing governance system, which is the framework. Okay, so before the before the organizational security culture framework, these were the results that I got. So after the surveys, structured interviews, 40% was seen as a policy awareness gap, 40% of non-staff. Yes, 40% of non-staff held a misconception in the security, 25% received no training, 10% reported regular following protocols, and 50 expressed dissatisfaction with existing security tools. Okay, so we move into the demonstration phase. So this demonstration phase structured a 4-phase pilot in the institution, starting with the baseline assessment and planning. The baseline assessment and planning, it was when we collected data using the surveys, the audit data to confirm empirical gaps, the data analysis, and shape the organizational security deployment strategy. The component testing was the second phase, where each of the 5 components were piloted individually, meaning independently, using a test, evaluate, refine cycle, which is the iteration, gathering feedback, and validating it. Tools were used, as specified here. Nessus was used for the vulnerability scanning, module LMS for the training, delivery, KeepNet, phishing simulation, and Azure. For the 4th phase is the integration and piloting, which is bringing IT, where we brought the non-IT and IT cohorts together for just real-time tracking through log surveys and incident reports. And then the 4th phase was the full deployment, rolling out the wide training, embedded automated compliance monitoring, and integrating security KPIs into annual performance reviews. Okay, how was the framework evaluated? The framework was evaluating using a dual approach. Okay, using a dual approach, expert panel review, which used a multidisciplinary panel, academic researchers, cybersecurity practitioners, which which evaluated the framework for functionality, consistency, completeness, accuracy, reliability, performance, usability, and organizational fit. And then for the KPI measurements, 5 strategic key KPI objectives that were tested on is the policy, awareness rates, phishing, susceptibility, compliance violations, security training coverage, and incident response rate. So these are the results after the framework was deployed, was demonstrated. Okay, and then we move over to the 7 evidence-based refinements. So For the evidence-based, based on the lessons learned during the implementation, these are the 7 base refinements. So these refinements include the modular customization, emerging threats, guidelines, maturity matrices, gamification of training. This is to make it interactive, the quarterly refresher courses, the role-based access control, enhancements, and the automated compliance. Okay, so once the most important, the most important design decision of the organizational security culture is its tiered scalability. So the tier 1 is the foundational organizations, these with no formal policies and no dedicated security budgets, being at risk of risk assessment security policies. The developing organizations activate training and awareness and compliance. So the entry point will to activate now training, awareness, and compliance to reinforce policy. The third one is the advanced organizational profile. All components operational, see continuous improvement. These ones can fully deploy the organizational security culture with the KPI dashboards and continuous maturity loop. Okay, so the contributions and future research is to the theoretical and practical contributions is that the research, my paper validates the way Gijo 2025 and Spinner and EK generic frameworks underperform in low, that generic frameworks underperform in low resource contents. It confirms the Shin's model, the durable gains come from addressing underlying assumptions, not just technical controls. Operationalist balances scorecard, the logic for the cybersecurity governance, and the operational toolkit, which is a conceptual framework plus the operational roadmap plus the KPI dashboard. In conclusion, the staff policy awareness post-implementation increased to 95. I printed out the 7 evidence-based refinements from the organizational security to make it more of a continuous maturity loop. The 3-tier scalability of the new cybersecurity culture framework, and the 8 criterias which the expert panel confirmed for framework validity. These are my references and any questions.
Thank you, Helene, for the nice presentation. I have a few queries. So how you collected the data? Am I audible?
Yes, you are audible. It was done purpose sampling for a specific institution, which I did not apparently for a specific institution. So what happened was, how I collected the data was through interviews, surveys, questionnaires, and policy audits. That's how I managed to do my data collection.
Okay.
Yes,
so you have used some previous concept methodology and you have applied for your region, right?
Yes.
Am I correct?
I can't hear you. I've used what?
You have used the methodology from some paper and then you applied that methodology into your
yes,
paper, right?
I've used
I
used the methodology from my paper, actually, my paper, my
okay.
thesis.
Okay,
Yes.
thank you.
So this okay, sorry.
Hello, this is Dr. Hirok. Hello.
Yes. Hi.
Eleni, yeah. It was a nice presentation. So just I have a few queries. What is the population size? Can you tell me about your population size? How much data you have selected, or how many interview you have conducted, and how many questionnaire you have distributed among the staff?
Okay, so I chose a specific public institution where I collected data. If I'm not mistaken, I gave my interviews were around about 10 from different departments. Yes, and the questionnaires that I gave out were, if I'm not mistaken, 25. from subsets of now the different departments of that public institution.
Okay, it's a random sampling. Am I right?
Pardon?
It's a random sampling only because in an organization you have almost 500,000 staff. No, you have only selected 25 staff for your study. That means it's a random sampling. Am I right?
That yes, okay, I can say no, not actually random sampling because
Then how you have considered this 25 staff?
The staff complement for that specific institution, there are only 50.
Oh, which institution?
I cannot name the institution at this point.
Oh, okay. So do you have the questionnaire format with you so I can say that what types of question you have prepared for collecting data?
Do I have it here with me? I'll have to look for it and see.
Okay. Okay. If you show me, if you have, if not, then I have the next question to you. What methodology was used to evaluate your effectiveness of your framework? What methodology was used to evaluate the effectiveness of your framework? Do you have any idea on this?
Pardon? What?
What methodology was used? Yeah.
I used MIST methodology.
MIST methodology to evaluate effectiveness of your framework.
Pardon?
Do you employ any quantitative metrics there?
Yes, for the quantitative.
Okay. I think we can move to next presentation. Thank you for your nice presentation.
All right. So next we will have Anirudh B, who will be presenting analysis and evaluation of static noise margin in SRAM cells with multiple defects. Anirudh, you may now begin.
Okay. Is my screen visible?
Yes, it is, but please speak up.
Please make it full screen.
Sir, can you see my screen?
It is visible. Yeah, it is visible. You are audible. Yeah.
Okay. So, good morning. My topic is analysis of stability and behavior of SRAMs in presence of multiple defects. The contents of the slide are need for memory testing, objectives of research, functional fault models, methodology of analysis, comparison of different static noise margin obtained, and experiments at different process corners. First of all, I will explain what is the need for memory testing. So as we know that as technology advances, the size of devices shrink. So the percentage of defects appearing in integrated circuits increases significantly. So it is important to detect these defects at maximum fault coverage within minimal test time. The objectives of research are: first one, investigation on variation in stability and behavior due to multiple defects in SRAM, calculation of static noise margin for multiple symmetrical defects, effects of different process corners in static noise margin, that is fast, slow, slow, fast, and slow, analysis of variation in static noise margin with temperature and voltage. This is the SRAM cell I have designed. Here we can see two of them connected back to back, and here we can also see the access transistors that are connected to the bit line and also to the word line. These are the different types of functional fault models: stuck-at fault, stuck-open fault, transition fault, read-destructive fault, deceptive read-destructive fault, and incorrect read fault. This is the methodology that I have adopted. I first designed an SRAM cell, then I simulated it in LT-SPICE, and I generated the butterfly plot curve. Then I simulated it at different process corners, that is temperature, voltage, different process variations. Then I took the inverter mirroring and superimposition, and I extracted the DC transfer characteristics, and from that I calculated the static noise margin. This is the butterfly curve of the golden SRAM cell. From this we can see that the width of the lobe is 255 millivolt, which shows good noise immunity. Then I took the butterfly curve of the golden SRAM cell for read operation. Here we can see that the width of the lobe is 156 millivolt. Compared to the golden SRAM cell, the width of the major lobe decreases, which shows reduced cell stability. Then I took the butterfly curve of multiple resistive defects. In the presence of defects, we can see that the width of the lobe has decreased significantly, that is around 78 millivolt. So this shows significant stability degradation. Then I did butterfly curve of multiple resistive defects, that is DF4, DF4C. Here we can see that the static noise margin value is 153 millivolt. So this has reduced the width of the major lobe significantly, indicating stability degradation. Then I carried out the feasibility of the technique at different process corners, that is fast, slow, slow, fast, slow, slow, fast, fast. I took the nominal voltage as 1.1 volt, and I tested the stability of the SRAM cell at plus 10% to minus 10%, that is 1 volt and 1.2 volt. And I also check the stability of the SRAM cell at temperatures of around minus 40 degrees Celsius to 125 degrees Celsius. These are the static noise margin values of the SRAM cell in the presence of defect DF3, DF3C, and DF4, DF4C. In the presence of DF3, DF3C defect, we can see that the static noise margin value is around 76 millivolt to 78 millivolt, and in the presence of DF4, DF4C defect, we can see that the static noise margin value is around 152 to 153 millivolt. Now I have considered slow process corner condition. This is the worst possible process corner condition that we could have. So I have evaluated the stability of SRAM cell in this slow process corner condition, and we have obtained the width of the major lobe as 76 millivolt, which shows stability degradation. Next, I have carried out the evaluation of stability of SRAM cell in the presence of DF4, DF4C under slow process corner condition, and we have obtained the width of the major lobe as 152 millivolt. Now I come to conclusion. So results show that multiple defects introduce reduction in static noise margin as compared to typical defect-free value reported in literature. Moreover, the impact of these defects in static noise margin is systematically evaluated under varying temperature conditions, supply voltage, and process corners to thoroughly investigate their effect on SRAM cell stability. These are the references. Thank you.
So thank you, Anirudh, for completing your presentation in time. I have few suggestions. When you present figures, always provide what are the parameters in x-axis as well as in y-axis.
Oh, okay, ma'am. Okay.
And Professor Hero, if you have any questions, you can ask.
So, hi, Anirudh. You are doing MTech or BTech?
Yes, sir.
You have completed your BTech or MTech. This is your dissertation study or something project?
Sir, I am not able.
Am I audible to you?
Yes, sir. Yes, sir.
Am I audible to you?
Yes, sir.
Okay.
So what are you studying now? You are undergraduate student or master student?
Master, sir.
Master. This is a
Master.
project.
Master of Technology.
Okay. So you have mentioned 4 objectives in this presentation. So what is the outcome from the 4th objective? I have not seen through presentation.
The outcome is that although in the presence of defects like presence of multiple defects, although this the width of the major lobe, that is the static noise margin value, is reducing. Still,
Okay.
the SRAM cell is stable. So in that
Okay.
condition, we will not be able to even during testing, we will not be able to identify the presence of such a fault.
So you go to aesthetic noise margin slide. So I have one doubt there. So just I want to know. Go to aesthetic noise margin slide.
Okay.
Because you have not given the slide number, that's why I have directly point out. Yeah, here, so I have one doubt. So in a context that DF4 and DF4C defect in the ground path, okay. So a higher SNM, this is 153. You can see there. What is the underlying reason for this difference? Just I want to know.
What is the?
What is the underlying reason for the difference? In the outcome, you can see DF3 it is 78 and 76. Here it's at DF4, DF4C is showing 153. The reason behind this difference, what can you share me the details?
Sir, DF3C means it is a different fault, that is read destructive fault, and DF4C is deceptive read destructive fault. These are 2 types of faults. So when the DF3C, that is a read destructive fault, appears, the read destructive fault appears in the power supply path. So in the presence of such a fault, the static noise margin value is 78 to 76. That means the stability is very low. And in the case of DF4C, that is in the presence of deceptive read destructive fault, the static noise margin value is 153 to 152 to 153, which shows higher stability as compared to that of the read destructive fault, that is DF3C.
Okay, got it. So thank you for your answers and explanation. So we can go to next presenter now.
Thank you, sir.
Yeah.
All right. So next we have M. Santhia, who will be presenting Federated versus Centralized Learning for Pneumonia Detection, a cross-architecture comparison of SVM, CNN, and LSTM on chest X-ray images. Santhia, you may now begin. Is Santhia or any of her co-authors present in the meeting? All right. So in that case, we'll move on to the next presentation. So next up, we have Pranav Srinivas, who will be presenting From Administrative Data to Policy Intelligence, an Explainable and Accountable Governance Framework. Pranav, you may now begin. Pranav, please unmute. Excuse me, Pranav, you are on mute. We cannot hear you.
So we are not audible. Please check your mute unmute button. Dear presenter, please check your button.
Hello.
Yeah, hello.
Very good morning, sir. Sorry for the inconvenience caused.
Okay, no issue. Yeah.
Very good morning, sir. Our title is From Administrative Data to Policy Intelligence, an Explainable and Accountable Governance Framework. And I am the co-author along with one of my classmates, and all the others are faculties here. Now, the introduction was public policy relies heavily on the administrative data experience and intuition, while large amounts of the government data remains underutilized in the decision making. We have seen in all most of the countries this situation occurs. There is a lack of integrated cross-sectoral data usage, which leads to fragmented insights, inefficient policy execution, as well as weak outcome evaluation. And the increasing policy complexity at state and the district levels, particularly for India, as we chose the case study to be, so I've written state and district levels. And it demands explainable and evidence-based decision-making frameworks. Now, the problem is there are huge amount of data, that is large volume of administrative data, but it is weakly used for verifiable evidence-based policy making. And this lack of cross-domain data integration and administrative silos prevent cohesive analysis, leading to inefficiencies and poor policy evaluation. The policy decisions remain reliant on intuition and fragmented insights, reducing foresight, accountability, as well as public trust. As we can see, outrages so many times in the country because of wrong policy implementation, because of not seeing the or not verifying it with the data properly. Thus, there is a need for the transparent, explainable, human centric system that ensures data integrity and decision making and all the other parameters, which improves policy implementation without replacing the administrative control. Now, the literature review. Say, suppose when we thought of this problem statement, converting this abstract idea into real-time software deployment for any policy which we could have thought of. First, we went to the literature review. That was Zafar 2021, which made a big data in policy making. But it had a very good contribution where it helped improve policy making in urban planning as well as education, whereas it lacks qualitative and quantitative assessment. Whereas the second paper, Maynard, which has policy analytics in environment, which makes empirical analysis. Empirical is only related to the logic, but the scope was actually confined to certain extent of our thought. And certainly, again, after the papers which I will be seeing through, the Young 2023, the new public analytics was a conceptual framework which defines new administrative paradigm, and it was completely conceptual. Later, the AI in SDGs was the topic of Zimba et al. 2024, which has the integrative literature review, identifies AI applications in sustainable goals, when ChatGPT and other artificial intelligence was taking a boom in each and almost every domain of the spheres of work. And the last, which is of our most important,
Dear present, please skip this literature review. You go to next slide. Okay.
I thought of telling the only important one. Okay, sir. And the last one, the Batul and Musa, data-driven public policy design, was conceptual and it had lack of empirical evidence. So we thought of this problem description. And what were the research gaps which we observed after surveying around 25 papers was the existing approaches are predominantly conceptual, survey oriented, or domain specific in nature with limited empirical validation or inadequate applicability to real time executive level governance. The current system fails to provide a human centric as well as accountable framework which has to meet without fully automating the policy decisions. Now, the framework which we proposed and implemented experimentally was for the Manrega dataset of 2023 at the district levels in the state of Karnataka. First, we ingested the data, collection of the execution level administrative data from the district level. It includes all the other parameters of age, names and other things, which includes expenditure, workforce engagement, service delivery time, as well as the payment timeliness. The data ingestion performed in read-only mode to protect the existing administrative systems, and it retained only policy relevant and non-personal indicators, eliminating sensitive data, as I mentioned, name and age, which were the say suppose sensitive data. Now the pre-processing is all the standardization in the cleaning of administrative data, removal of null values, obsolete values, and redundant values and irrelevant records was done. Now the major step here was integrity layer, the cryptographic hashing, SHA-256 was ensured that the data was tamper evident and therefore auditable as well as accountable for any of the future questioning on the work. The phase 3 of this paper was feature engineering and aggregation. The aggregation of the data at the district levels into policy intelligence records. The key features included expenditure, workforce employment duration, and the payment discipline. In the 0 to 1 scale, it computes the delay risk based on the payment timeliness. Now, mainly with what the title was for forecasting and the decision support, explainable policy intelligence, the decision tree regression for analyzing execution delay risks, SHAP analysis for the complete insights at the global as well as the district levels were taken. Now in Karnataka, we have 31 districts, which I'll be showing in the further slides. The outputs were policy-driven visualizations, heat maps as well as risk mapping, identification of high risk districts in the top 10 to 15%, which will also support, say, suppose if any bureaucrats have problem with our software or this ideology, it also supports the human in the loop decision making. And this is the flowchart for the same. Now, what were the results and the discussions that we observed after a coherent framework which we had designed? It transforms the execution level administrative data into interpretable analytical evidence using the cryptographic verification as well as the explainable models, ensuring transparency, verifiability, and operation relevance in governance. This positions the policy intelligence as a governance assurance mechanism that supports monitoring, prioritization, and management while maintaining the accountability. However, we also have our limitations of the institutional dependence, that is the use of aggregate data and the trade-off between explainability and predictive complexity, indicating scope for the future research. Now, say suppose any administrator has to check for the Manrega data set and see whether it's getting implemented properly in the state or in his district, he just can use this software which you had designed. But there are some more limitations to it, which we have to further find out. Was the effectiveness of the framework that depends on the institutional as well as the political and operational realities, including the willingness to adopt the analytical insights. Public sector decision making is still influenced by the legal demands, administrative structure, and political factors. So it is not so easy to make it a very scalable software or any model as such. The use of explainable models and aggregated data, this may limit the analytical sensitivity because every administration is completely different from what we think of using the models or train it, and restrict the fine-grained micro-level policy analysis. But I would also like to add on to this point, and as a defense to my research work, that the validity, this is a valid research work that we have done because the proposed framework, it demonstrates effective applicability on the real-world administrative data of the Manrega 22-23, which successfully identifying execution level risks and the regional disparities through the interpretable analytical outputs. The use of explainable decision tree regression with SHAP analysis ensures reliable and transparent identification of key execution drivers, and the mean absolute error is 0.355, which is comparatively lesser to the any work which hasn't come till now. Unlike the conventional approaches that prioritize the predictive complexity, this model achieves an operational relevance and interpretability, enabling practical deployment within the government systems, because this can be run in a Python code and no new design for software or any cost would be as of much compared to the model which we have
Dear
proposed.
presenter, please summarize your presentation.
And the conclusion and the summarization is it promotes policy intelligence as a governance assurance device, and it highlights limitations such as institutional reliance and the political influence. For that, we had to lessen our research work based on the topic. But somehow we have tried to convincingly convert a abstract concept into somewhat what a software can help the administrators in this perspective.
Hi, Pranav. Nice presentation.
Thank you, sir.
So I have one suggestion and 2-3 doubts.
Yes,
Just
sir.
want to clarify from you only.
Yes, sir.
First one is suggestion from my end that you have mentioned your literacy review in a table form, no? So no
Yes.
need to mention in a table form your literacy review. Okay, just put
Okay, sir.
within a 4 line you can cover your literacy. What output you are getting for those literacy. Okay. So
Yes,
now
sir.
this is trending is going on. No need to give. This is a old style. Okay.
Yes,
Now
sir.
you
Yes, sir.
can input trending things how literacy can be converted in a 4 to 5 lines.
Yes,
So
sir.
and next, my doubt is how much data you have selected from MREGA. This is a scheme, central government scheme. Am I right?
Yes,
Is
sir.
it
It is a
possible to
central
get
government scheme introduced in the year
how you are
2000.
collecting data? Is it government is allowed to get the data?
Yes, sir. It is available in the Karnataka government website, which you have included in the paper. And the data
Okay.
was for 12 months. And Manrega is usually for calculated for the year basis. And even
Yeah,
if
that I
the
know that because I have a vast experience with the dealing with that Panchayat level schemes. Okay, this is a Panchayat level scheme only.
yes, sir.
Yeah. So MREGA is basically dealing by Panchayat only, not
Yes, sir.
directly executed by central government. So I have a good experience with this. How this government is allowing you to
Yes,
exclude
sir.
their data or
Yes, sir. The data is publicly available in the government website. So we accessed it from there itself.
okay, how much data you have selected for this study?
That is there in the execution, sir, file. I'll open it and check it, sir.
Okay. So you're
Actually,
supposed to mention this in the methodology area, okay, in a framework also.
no, we had mentioned it
So,
in the paper in detail, so thought of not repeating it
but
here.
in the presentation, we supposed to know,
Oh,
understand,
yes.
no, how much data you have selected for this study.
Yes. It was for
So,
the year 2022 to 2023, and the data is complete data of whatever has been presented in the government website for all the 31 districts of Karnataka.
okay. So next, I have a one query that what makes your framework different from existing implementation framework in this domain?
There was no implementation. See, sir, this is a very abstract concept, as I said in the before itself, because policy
Okay.
and software intelligence and policy would never come into the same domain sometimes, because
Okay.
policymakers have always chosen to, as in the current scenario in the country also, there is certain things
So this
going
is
on.
a proposed model only, framework only.
Yes, sir, it was a model which was
Model, yeah,
yes, sir,
got it,
which
I
we
got it.
model.
Okay, okay, fine. So now I would like to give over to Dr. Bonishavar. So if Madam has some query or something like that.
Pardon, sir?
I over to our course here person.
Thank you, Professor Viraj. So I have one query. Do you
Yes,
have
ma'am.
any quantitative conclusion from this research?
Yes, ma'am. The quantitative conclusion can be said that the mean absolute error for the first time on the testing data was 0.355, which is comparatively, not comparatively, which is considerably less, as I can say, because there was no model as such proposed for, because each and every policy is completely different from the other. And the explainability which we had chosen also provided in line with the data which we had already observed, because policy usually is from the in the observed in the eyes of the administrators of the bureaucracy as well as a software engineer.
Okay, okay, thank you, Brent. Alisa, we can go to next presentation.
All right. So moving on. Next up, we have Reet Ginotra, who will be presenting machine learning-based depression detection from text using hybrid feature engineering and ensemble models. Reet, you may now begin.
Yes, ma'am. Greetings, all the judges. Am I audible?
Yes, you are.
Okay. Let me just share my screen. Just a second.
Reet, you could try sharing your screen without sharing the audio. I think that should fix your mic issue.
Okay, sure. Is it visible now?
Yes, it is.
Okay, thank you so much. Okay, so greetings, judges. So this is my presentation. I have actually made an app, mental health companion app, and under that, there is this paper that I have written, which is machine learning based depression detection from text using hybrid features, engineering, and ensemble methods. So basically, these are the authors and co-authors. Let me get straight to the agenda. So, as an abstract, as we try to explain that we know that depression is, a largely common problem. So our paper recognizes to identify the problems and to basically recognize depression. And how do we do that is like the traditional methods were there, but now we have several classification methods like logistic regression, random forest, XGBoost, and light GBM. In the paper,
Dear presenter, please make it full slide mode. Just
sure,
click
sir,
the
I'm so
presentation
sorry.
mode. Yeah.
Sure, sir.
Okay.
Sir, is it
Yeah.
fine
Thank you.
now? Sure, sir.
Yeah, it is fine. Yeah.
Okay. The main key model of this paper is that we have used these uh, new models, and we realized that XGBoost gave us the highest accuracy. And the key feature of this is that we got to know that the traditional methods were not able to, even after getting the new advanced complex methods, they together were not able to be scalable. So that is what this paper researched on and fixed about. Like we introduced the idea of it, depression is an engaging mental health disorder, and NLP and machine learning has got an increase in the ability. We have so much work done already on it, but still we have not reached the maximum scalability that is yet to be achieved. Like we know the term frequency, inverse document frequency, where we extract the features. We will have a better explanation of this in the data description in the further slides. So this is the basic introduction about it. The transformer models and the large scale models, especially BERT, we have seen that play a major role in detecting in these NLP and all. When we talk about the literature review, so
Please
in
skip this literature review. Just go to the research gaps only. No need to discuss literature
okay,
review.
sir. Okay, sir.
Okay.
So the main key thing is that like you can just see the models mentioned over here. We have already used, but then again the same things come that like TF, IDF has been used and everything. We have high performance model, but we lack in scaling them. That is where the research gap is main. So, what our data, how we do it is, methodology of ours is that we took a data set from Kaggle, and we had 5 features of it, and we dropped the missing values and all. We selected, and this is how we have like a visual representation of our data in terms of the features. You can see that we have in terms of age distribution, then there is that box plot graph also for the age category, that teenage and something, and then here goes with the male and female, teenage and young age. So how we pre-process the data is basically can be easily explained in 3 ways: text pre-processing, feature engineering, and TF-IDF, factorization, and feature fusion. What plays role here is that text pre-processing, we just first clean the data. Then feature engineering, we extract the key features that we actually need to study. TF-IDF factorization, we like if someone says I am sad, so we extract this sad and we count how many times it has been there. And feature fusion is the main key step that combines all the features and actually makes us understand that on a that is the main key thing that we are basically looking for, combining all of the features and getting us to know that what features have more importance relatively and others do not. For example, ism are common, so they'll not be counted, but depression, how many times it has been counted, it will be relatively and numerically counted. So these are the result and analysis when we have used these models: logistic regression, random forest, XGBoost, and light GBM. As you can clearly see that the accuracy with the XGBoost is the maximum over here. Same goes with the F1 score. and we know that these two when are the maximum, which means we have achieved our goal that we were basically looking for. Same here goes with the curves, area under the curve mentioned as here. Here is a graphical representation of the results that we have shown in the previous slide in terms of the sheet in numerical way. This is another graph that is for the area under the curve. We can see that it has been mentioned with the color according to all the models. And we can see that XG boost goes in the middle, not overfitting and nothing like that. Since we used this SMOT with this XG boost because it nailed out of all others. So we have a result based on it also. Same is the graphical representation for it for XGBoost, Light GBM, and Random Forest when we just took the top 20 features so that, to try on the first few features. Then this is our conclusion, which is that the presented research introduced an integrated machine learning system to detect depression, as we know. The proposed system is more effective to capture both linguistic and emotional patterns associated with the depressed expressions by combining the textual representations based on TF-IDF methods. As I clearly explained that how much this played a major role in extracting the key features and then future fusion took place. And we also observed that how XGBoost out of all the given models, random forest and every other, even light GBM, but which follows the tree leaf method, but the sequential decision tree method, the boosting one, got more of the accuracy and FN score for the same. These are some references attached. Thank you, everyone. This was my PPT. Do you all have any questions?
Thank you, Reed, for
Thank you,
this
ma'am.
nice presentation. This is a very good topic. So I have just a few queries.
Yes,
So you
ma'am.
have shown that you have collected the data using linguistic data and some emotional data. So how you have collected the second one? How you have
Uh,
considered that factor?
Ma'am, we have picked this data from Kaggle, but we were also collecting side by side more of data from Google Forms. But since that has not been collected in a much way, so we took from the Kaggle one, which
So
is
what are the
already.
parameters for that? I mean, how you are verifying that emotional pattern in your data set with
Ma'am, we
what
have.
parameter?
Yes, ma'am. Ma'am, we have basically identified and categorized them basically on the basis of their age and labels, and
Hmm.
then like their emotions during the day. These are the labels,
Hmm.
and the age and young age, the teenage, and then male, female. That is where we have categorized. The data set
Hmm.
is basically comprises of that.
So, okay. Next question. So, how you have already developed one app. So, how you are planning to implement in practical scenario?
Sure, ma'am. So basically, the app basically involves three sets: front end, back end, and ML model, right? The front end UI design we're doing. The back end involves the data set basically to have a chatbot in it, and that needs like to process from a database, right? So this is where this key thing comes in, that we realize that which model is better for us. This model, we will basically be using it as an open AI chatbot that will
Oh.
help with people understanding their emotions. Like there are many
Hmm.
other existing apps like AstroTalk and others. The same
Hmm.
vision goes over here in helping with people understand their mental health. And we
Oh,
are also thinking of adding the therapist thing for later, so that it could be monetized for later, so that we detect at an earlier stage that this person need more than just talking, and that a therapy is needed.
okay, understood.
Yeah, then
Understood.
we'll
Hmm.
get to that. Yes, ma'am.
Okay,
That's
thank
the
you,
vision.
Reed.
Thank
As
you so
we have
much, ma'am.
limited time,
Sure,
so
ma'am.
that's why we have to conclude here now. If Dr. Hirak has any questions, then he can ask.
Sure.
Already, ma'am, already asked my questions also. Just I have a one query only. So my query is that what measures are you going to take to ensure user privacy and data protection?
Sir, I'm so sorry. Can you please repeat your question? You were a little less audible.
What measures are taken to ensure your user privacy and data protection in your apps?
So since this is just like we first developed the front end, and
Which
now we are
language
working
you
on
are
the
using for designing the front end?
so React.
Okay. And backend? Which
So
database you are managing?
backend, we are looking for Node.js, but
Okay.
we are slowly learning and doing. So it's like the three stages. I'm individual in this, so
Oh,
we are dividing the work.
okay. In this
Okay.
area, you are doing PhD under Oculus?
No, sir, I'm doing BTech right now.
Oh, BTech night. Okay, 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 okay.
Yes, sir.
Because I know your guide, that's why.
Okay, sir.
Okay, okay, fine. Well, thank you.
Thank you so much, sir.
Yeah.
Thank you so much.
All right, so now we'll move on to the next presentation. And next up today, we will have Bobby Eclairin, who will be presenting MMSU D-Trail, Development of Document Tagging Repository and Information Locator for the Records Office of Mariano Marcos State University. You may now begin.
Hello, good afternoon. Am I audible?
Yes, you are.
Let me share my screen. Okay, to our moderator. Oops, I'm sorry. I have. Okay. So to our moderator, session chairs, and fellow researchers, good afternoon. Today, I will be talking about our developmental research at the Mariano Marcos State University here in the Philippines. My presentation will be discussed in the following order: the introduction, objective of the study, materials and methods, results and discussion, as well as the conclusion and recommendation. To begin with,
Bobby, I'm so sorry to interrupt. I don't think you're changing the slides. We can't really see. We can only see your first screen.
okay,
Okay.
So to begin with, document management is a challenge that affects organization worldwide. So across institutions, the sheer volume of records we handle daily makes retrieval and preservation a consuming task. Quick access to documents enhances productivity and saves time and money. However, traditional paper-based systems and fragmented digital repositories often lead to inefficiencies, delays, and even data loss. And when disasters strike, like floods, earthquakes, or fires, these vulnerabilities can result in significant damage. So technological advancement have already paved the way for digital transformation. Beyond efficiency, digitalization also supports sustainability by reducing paper consumption and aligning with environmental responsibility goals. In short, it strengthens both productivity and governance. Here in the Philippines, the government has taken bold steps to accelerate the shift to adopt digital strategies aligned with the national roadmap, that is the Full Digital Transformation Act of 2020. Digitalization boosts ease of doing business and perhaps combat corruption. This framework enhances transparency, improves service delivery, and supports sustainable development. But policies alone are not enough. Institutions need practical tools to make digitalization work. For record managers, solutions such as tagging and repository management software are vital. They allow systematic organization, quick retrieval, and ensures that organizational knowledge is usable and accessible to all constituents. More importantly, they transform document management from a reactive task into a strategic function that supports decision-making and institutional resilience. So at Mariano Marcos State University, this challenge is especially pronounced with multiple units handling diverse records from accreditation files to memoranda. Management of such documents is a tedious and challenging task. Therefore, there is a need to develop support tools that will digitalize the collection, sharing, and organization of documents and help manage these resources efficiently and effectively. This is where our initiatives, the T3L system, document tagging repository and information retrieval comes in. So it is designed specifically for MMSU, which contributes to localized digital transformation and offers a scalable model for other state universities. So this project aims to centralize the repository of institutional files, digitize documents which can facilitate efficient collection, organization, and sharing of information. So it aims to employ pre-planning activities and design of the system, develop and test the system, as well as the user acceptance testing, evaluation by the end user. The agile development software methodologies was used. This is because agile development prioritizes flexibility and continuous improvement over rigid sequential processes. And it has different phases that include requirement analysis, planning, design, develop, release, track, and monitor. The conceptual framework of this study illustrates the dynamic relationship between the global challenges, national policy direction, and institutional application. So in MMSU's use case, the trail embodies the development of a tagging and repository software, which will deliver a secure and accessible records across the university, thus providing an efficient, resilient, and sustainable document management system. JavaScript, PHP, Laravel framework are the software used in developing this system. We also use the high charts for graphs and data visualization, MySQL, design and implementation of the databases. So the participants in the user acceptance testing was carried out using census method, also known as the complete enumeration survey, to evaluate whether the developed systems align with user expectation and
Dear presenter, please go your findings and conclusion.
Okay, it has the following descriptive rating from poor to outstanding. Okay, the participants from the administrators up to the college secretaries. There are actually 70 participants. So here are some of the features now of the D-Trail. So it has it is a document tagging repository app that can be accessed through the web using internet, such as laptop, desktop, and tablets. User must have an account to be able to proceed to the system. It has documents with tag. Can be easily through its My Documents landing page. A granular access control. Okay, it can be viewed by the designated privacy levels such as university, college unit, department, or as well as private level. It has also feature team modules, offers a secure collaboration environment. Okay, collaboration. And then for the result and discussion, again, a total of 70 participants from the different units evaluate the system. And in the table, it shows the overall mean of the system according to the user acceptance test with a score of 4.36. And high ratings in productivity, user friendliness, and document organization validated the system's effectiveness, as well as the slight lower score in scalability highlighted areas for future enhancement, particularly in handling large volumes of documents. So for the recommendation or conclusion, the Agile model was employed in designing, developing, and implementing the features of the tagging and repository system. The tagging and repository system received an overall score of 4.36, reflecting a very satisfactory rating from end users. This suggests that the developed support tool designed to digitalize the collection, sharing, and organization of documents is capable of efficiently and effectively supporting resource management. So for the recommendation, it is recommended that the subsequent version may use contextual tagging, optimize the system for infrastructure, conduct regular workshops, and consider adapting the system for use in other SUCs. And the author wishes to thank and acknowledge Mariano Marcos State University for its full support throughout this endeavor. So here are the references, some of the references listed. Okay, thank you so much, and good afternoon.
Yeah, thank you. It was a nice presentation. But I have a query, one suggestion also, one query also. So you are working on document management system. So
Yes, sir.
are you using or incorporate any kinds of metadata schema support for functioning your retrievable system? You understand retrievable system?
Come again, I'm sorry. Can you
Do
repeat
you
the
have
question?
any do you have integrate any kinds of metadata schema to retrieve your documentation?
Yes, basically, it was designed primarily for MMSU. Well, it can also be implemented.
I am basically asking about retrieval process, how your retrieval function is working. Means if I'm searching some document in your archive, so what kinds of metadata should I incorporate in the for searching a document in your archive?
Okay, for the metadata, it will give us the documents, particularly the features or keywords that has been um, uh,
You are not following
inserted in the
international
database.
standards. Am I right? You are not following international standard like Dublinco metadata schema is there, IPTC is there, so LOC is there, like Library of Congress. So do you have any kinds of idea about those kinds of metadata schema? Or I can suggest you can integrate those kinds of metadata schema in your archive system. It will be good for retrieval of any kinds of documentation or information to your archive or to your tools.
Yes, we use the schema for of our database.
Okay, so one more suggestion I can give you that you try to incorporate handle ID.net, okay, which will be unique identification number for your every document. It will be good for retrieval information.
Okay. Actually, we
Okay,
have
it is
a unique ID for every document inputted also in
yeah.
the
The handle ID is you need to purchase it. It is not free or it cannot be developed. You have to purchase handle ID unique number for your archive. So against every documentation, you have a unique number to retrieve the information.
Okay, thank you so much for that recommendation, sir.
Yeah, thank you. And over to Dr. Bunisha.
I have no questions. We can go to the next presentation.
Okay, so we'll begin with the next one now. Next up, we have Gautaman SP, who will be presenting NFC-enabled AI-driven pharmaceutical supply chain framework for circular economy sustainability in India. Gautaman, you may now begin.
Hello, ma'am. Am I audible?
Yes, yes.
Yes.
Please
I'll share my
complete in 8 minutes, okay?
yes. I will share my screen now. Is my screen? I'll just share my screen. Is my screen visible?
Yes, you can present now.
Yes. So, good afternoon, everyone. I am Gautaman SP from Amrita School of Computing, Amrita Vishwavidyapeetham, Coimbatore, India. I am here to present our paper on NFC-enabled AI-driven pharmaceutical supply chain framework for circular economy sustainability in India. So, as a brief outline, I will begin with an introduction to the problem, followed by our proposed framework, experimental results, operational deployment strategy, and future work. So, as of now, India is currently the third largest pharmaceutical producer in the world by volume. And therefore, the efficiency and sustainability of its supply chains is a matter of critical importance. So currently, India follows the linear model of medicine distribution, which is take, make, and dispose. So this generates over 500 plus tons of biomedical waste per day. And this also causes an annual loss of $63 million due to the expired medicines. In order to combat this, the Indian government has mandated a shift towards the circular economy model through national policies such as a National Resource Efficiency Policy and the Extended Producer Responsibility Framework, which is in direct alignment to the UN SDG Goal 12, which is Sustainable Consumption and Producer Patterns. So in order to achieve this, our work leverages the NFC's inherent smartphone capability and interference-free short-range communication as the foundation for our AI-driven circular economy framework in the Indian pharmaceutical supply chains. So currently in the healthcare logistics, RFID is being used to trace the systems, but in India, we do not have a system which combines NFC with AI ensemble forecasting for our pharmaceutical circular economy. So some of the commercial pharmaceutical software such as March ERP and GoFrugal softwares rely entirely on the manual barcode-based stock keeping without predictive demand forecasting or interfacility redistribution. The major objectives of our system is to first develop an NFC on smartphone application, which is combined with Ensemble machine learning framework for real-time individual item level pharmaceutical medicine tracking. And the second objective is to enable a proactive 30-day demand forecasting to identify surplus stock before expiry and promote circular economy redistribution of the medicines to the facilities where the demand is more. And this is our this diagram illustrates our end-to-end framework system architecture. So the first layer is the hardware interface. And here we are using NFC tags, specifically NTAG 215, which are physically attached to the medicine units and are programmed with the NFC data exchange format, which is the standard binary format as per the ISO 14443. So the reason why we are using NTAG 215 is that it has an inbuilt memory and it can also be changed to the read-only memory, which will in turn provide a secure transition and prevent the pharmacist from misconstituting the data. The text records which are stored in the tag are the batch number, drug name, manufacturer details, expiry date, as well as the unique NFC tag ID for each individual medicine for the tracking purposes. In our experiment, we are using the Samsung S20 FE NFC reader for our testing purposes. The second layer is the mobile application, which we have built it in Kotlin for the Android application. This is the primary interface which will be used by the pharmacist, enabling them to scan the medicines, register the stock, perform the billing, view the inventory insights, as well as receive alerts. So here we are using an OCR model which automates the initial data entry from the NFC tag. So the pharmacist will not be able to forge or make any changes to the data, as the NFC tag data is read-only. And all this data currently we are storing it locally as part of the SQLite. The third layer is our analytical intelligence layer. So here we are using a cloud-hosted Flask REST API server, which receives the NFC scan data via a secure HTTPS protocol. And this is used to run our ensemble forecasting engine to generate the stock recommendations. The reason why we are using a Python Flask backend is because the computational power required for the ensemble forecasting engine is not enough in the mobile application, which either takes a longer time or it does not compute properly. So that's why we are using it as a separate REST API server. The final layer is the operational decision support layer. So here, the predictions which we have received, for example, the stock recommendation, we are converting it to the stock out date alert, so that the pharmacist will be able to identify when the data will be when the stock will be expired, and the near expiry alert system, which provides the pharmacist with the details and location of the medicines around the which will be expired, and which can also be sent to the sent to the redistribution purpose. We also have an NLP chat interface, which will be so that it will be easier for the
Presenter,
pharmacist.
please go to the conclusion. And if you have an implementation, please go with implementation and conclusion. We have a limited time now.
Yes. So as part of our experimental results, so we have tried with the individual 6 individual models as well as the ensemble model. So the 3 individual models, which are the statistical conventional forecasting models, they have a negative R square, which proves that they do not they are not able to so they are not able to like how I mean, like they are not able to model that irregular non-cyclic demands, whereas the individual machine learning models are able to get a moderate result. But the ensemble model which we have used, they are able to provide a tenfold improvement over the best individual model. So these are the visual representation of the results. So basically we have the data set around 55,000 records from the year 2020 to 2024. And as part of our testing, we have trained the model based on the first 4 years and validated it with the data on the 2024 on the final year. And this is for one medicine for one facility. And as per this first graph, we can see that the actual demand and the individual model predictions, the individual models are not able to handle the fluctuations which are happening due to the irregular demand. Whereas in the second graph, we can see that the ensemble model is able to generate the closer result compared to this. So as part of our operational deployment, we will be providing them with the stock out date alert as well as the near expiry alert system, which will provide the pharmacist, preponed results, so that they will be able to convert this into a redistributable assets, similar to the Jan Adeshi Kenras, which is the government based affordable medicine dispensaries instead of the disposal. And this follows the first expiry, first out principle in order to minimize the expiry driven waste. Therefore, we are able to reduce waste, reuse the near expiry medicines, as well as recycle and safely dispose the expired medicines. And the future scope is our validation, where we are testing the ensemble model on a real life transactional data across pharmaceutical networks. The second one is like we are planning for an life cycle assessment study, which will be able to quantify the environmental payback of rewritable NFC tags for the closed loop redistribution. And privacy is also an important factor in this retail pharmacy networks, as it's a medical information. So therefore, we are also planning to explore the federated learning such that like the data is being gathered from individual pharmacies. And finally, we are also planning for the extension towards the FSSI food supply chains, where we are applying the same first expiry, first out redistribution in order to reduce the food supply chain losses in India. And these are the major references which we have used for our research. And to conclude, we are able to demonstrate that combining an NFC on smartphone with the ensemble ML model can achieve a high forecasting accuracy, which in turn creates a scalable, low-cost, impactful circular economy solution for the Indian pharmaceutical supply chain. Thank you for this opportunity.
Okay, Mr. Prabhakaran, that was a nice presentation. As we have limited time, I'll ask only one question. Just go to slide number 7.
Yes.
Okay, here you have shown some R-square value. So what type of method you have used for this analysis?
Yes, ma'am. So as of now, like what we have done is like we have the data set which we have taken is for 5 years. So for our R-square validation, we have validated the so we have around 55,360 records with 64 individual medicine types.
Okay, understood. But what that you have performed any statistical analysis for that?
Yes, ma'am. So basically, we have.
So what statistical analysis you have used?
So actually, statistical analysis we have not, ma'am. We have only calculated the.
But you have shown
absolute
R-square value. So do you know what is R?
Yes, ma'am.
What is R?
So it's basically the demand of the medicine as per with the sales data of the actual.
Just check this one, okay?
Yes.
You just check what is R and what method you have used.
Yes,
okay,
ma'am.
thank you. I have no more questions.
Yes.
I also don't have any kinds of questions. So, Alisa, how many presentations we have now?
We have 3 more presentations.
Yeah, try to make it within 5 minutes. They can give it.
Sorry?
Within 5 minutes, they can conclude their presentation.
All right. Okay.
Okay.
So next we'll have Vijay Nirmala Baddala, who will be presenting Psoriasis Severity Assessment using Skin Biomechanics, a novel approach using deep hybrid models. Vijay Nirmala, you may now start your presentation. As the chairs have suggested, please keep it within 5 minutes.
Good afternoon, ma'am. I'm audible?
Yes, you are.
Yes, ma'am. Good afternoon. Myself, Vijay Nirmal. I'm working as assistant professor in AMC Engineering College, Bangalore. Today, I'm presenting my research paper titled as Psoriasis Severity Assessment using Skin Biomechanics. One second. So coming to introduction, psoriasis is chronic inflammatory skin disease. It is having red patches. The people are suffering with this are having mental stress and movies. For this, we are making the accurate assessment.
Madam,
your voice is echoed. Please check.
Okay. Ma'am, now audible, ma'am?
Yeah, very much, very much.
Yes. So psoriasis disease, the people are not leading normal life properly. For sake of that, we have made accurate assessment. Accurate assessment will give the important for proper treatment and monitoring. So coming to problem statement, currently severity assessment is through PASIS score. So it is completely depending on the dermatologist's visual manner. So different people, they will give different observation. So the assessment will be automatically, it is not proper in particular areas. So the motivation of this is to enhance the complete image with biomechanical properties like elasticity, viscoelasticity. Combining both, we can make more accurate assessment. So that literature survey, what I referred is, they are using traditional methods, PASI and body surface area, dermatologist life quality index. These things are they are using. So recently, machine learning and deep learning, they are giving, providing the CNN and SVM classifications for severity predictions. So
Sorry to
preferring
interrupt, ma'am. You can
Oh.
skip this part and you can directly discuss the metrology.
Yes. So our proposed solution is taking the dermatological image analysis by using CNN and also skin mechanical features like elasticity and stiffness. This model will give the severity score and classification, whether the severity is mild, moderate, or severe. The data sets here, I have used three types of data sets. ICTIS archive data set, in the 2,500 dermoscopic images have taken. Dermonet data set, 300 psoriasis images has taken. And synthetic biomechanical data set we have created based on the clinical values, as these are not available publicly. So these are the data sets we have used. So this is the sample, how it appears, the skin with the psoriasis. So first, after taking the data set, we need to make the data pre-processing. In pre-processing, we have used Gaussian filtering for noise removing. After that, contrast enhancement, color normalization, because by default it will take BG. So we need to make it the RGB. So removing artifacts like hair, side, any issues are there with the patches, these can be removed. Then these lesion segment is performed by using unit for affected regions. This is the data pre-processing pipeline. First image we are taking and resizing, noise reduction, color conversion from BGR to RGB, and normalization. Later we will go for the lesion segment by using unit. Then we will get the segmented thing. Next, biomechanical data pre-processing. These are the parameters: elasticity, stiffness, viscoelastic ratio, thickness. This way, from that, we are going to make the final pre-processed output. This final pre-processed output, this feature extraction, in this we have features like elasticity, stiffness, thickness, and viscoelastic ratios are extracted. These features are very important for the severity assessment in disease. So this is the hybrid model what we have used. This hybrid model, first CNN, whatever pre-processed input, it is given to the CNN for a visual feature. CNN extracts the visual features. Then biomechanical data is encoded through RSNet. Both features are combined in fusion layer. Then classification is performed using fully connected layers, SVM. So the output includes the severity score and classification. This is the hybrid model. So this is the model training. So the model training, we have taken 70% training and 15% for validation and 15% for testing. So when we have taken the severity, when it is mild, elasticity moderate, stiffness low, thickness slightly increased. Another thing is moderate, reduced, medium,
Madam, please
increased.
go to your findings and conclusion.
Okay.
Yeah.
So these are the results, different results. Next, this is the application. We need to reduce the subjectivity and improve the accuracy. And the conclusion is we propose the deep hybrid models, which combines the visual and mechanical features. This approaches significantly improves the psoriasis severity assessment. The main feature is, in future, I want to implement this real-time clinical environments for a better health support. Thank you.
Yeah. Thank you, madam, for your presentation. It was a nice presentation and nice things you have covered before your study. So I have one just query only. So which biomechanical parameter are you using for this study?
Sir, can you repeat the question?
Which biomechanical parameter are you using for this study?
No, sir, I didn't study.
You have not, but you are studying on biomedical mechanics, that's why. Biomedical things, that's why I'm asking.
No, sir. I have used for my research purpose.
Okay. So data, how have selected? Hello. Am I audible? Yeah. So data, how you have selected?
Sir, data, we have publicly available data. I have taken ICTIS.
Source need to produce during presentation. That's why I'm asking.
Oh, okay, sir.
Okay, yeah, fine. Then next presentation, Alisa, please go to next.
Thank you, sir. Thank you, sir.
Yeah, thank you.
All right. So next up, we will have M. Santhia will be presenting federated versus centralized learning for pneumonia detection, a cross-architecture comparison of SPM, CNN, and LSTM on chest X-ray images. Santhia, you may now begin. Please try to keep it within 5 minutes.
My PhD.
Okay. Am I audible?
Yes, you are.
Okay, thank you. Good afternoon to one and all present here. Thank you for the opportunity to present my work on federated versus centralized learning for pneumonia detection, a cross-architecture comparison of SVM, CNN, and LSTM on chest X-ray images. So AI has become very powerful in medical imaging, especially for disease detection using X-rays. So main challenge is data. Hospitals have very large amount of data, but due to privacy concern, they are not able to share it. So which violates the HIPAA and GDPR regulations. So in centralized learning, all this data must be collected in one place, which increases the risk of data leak and also violates this regulations. And another issue is class imbalance in real data sets. Some classes like pneumonia or some other classes are more frequent than the normal cases, which causes model to become biased. So in this work, I have taken a pneumonia, because it is a leading death-causing disease, demanding rapid AI-based diagnosis for chest X-rays. So all existing centralized models risks the patient's privacy and also suffer from class imbalance problem. So we proposed a federated learning with 3 models: SVM, CNN, and LSTM, in which CNN is a better model with reaching 84.6% accuracy. Let me explain federated learning in a simple terms. So it is proposed by MC Mahan et al. In 2017. So in which each client trains the model locally without sharing their own data with the server. So the server will not know about the data. They send only the model weights to the central server, and the central server aggregates the weights from all the clients using FedAverage, and then update the global model, and the updated global model will send back to the clients. So this cycle repeats for multiple rounds to improve the model performance. So patient data will never leave its source institution. So this is a visual representation of my federated learning, where client may be a hospital, banks, or any other companies, which do local training and give model updates to the central server, and the central server aggregates and update the model and send back to the clients. This is my related works related to this research, and this my objective is to develop a system that is that is suitable for real world healthcare environment. So we specifically compare federated learning naturally improves the class balancing problem, which reduces the risk of incorrect diagnosis. So we evaluated this model using the standard metrics like accuracy, precision, recall, and F1 score. Here we have taken a data set from Gaggle chest X-ray pneumonia, and it contains 5,216 images for training and 624 for testing, where you can see a severe class imbalance problem. You can see 3,875 images for pneumonia class and only 1,341 for normal, so which leads to a biased model and affect the accuracy of the centralized model. And also we have pre-processed the data set, that is we resize the images of this data sets into 64 cross 64 pixels, and we normalize them. For SVM, the data set is converted into flattened vectors, and for LSTM it is converted into sequential data, and for CNN it is reshaped into 64 cross 64. This is my experimental setup, where it contains 5 clients, and the image size for all the models is 64 cross 64, and it will be for 10 communication rounds. All 5 clients are participated in this setup, and we have used federated average for aggregation. So in centralized approach, we have all 5,216 images in one central server for training and testing it with the test data set. And in federated approach, the data is split across the pipelines using stratified IID partitioning, and aggregation method is fed average. This process is repeated for 10 communication rounds for all 3 models, and we have used the same test data set for both centralized and federated for fair comparison. So in centralized learning, we observed that model performs very well on the pneumonia data cases, but poorly on this normal cases. You can see a recall score for this. Here pneumonia 0.98 to 99, but for normal classes it is only 38 and 55. And also you can see accuracy for SVM is 76.6% alone, and for CNN which is 76.3%, and for LSTM it is 81.6%, and it also suffers from overfitting problem, where validation accuracy is 97 to 97%, but it is low for test accuracy, which is 76 to 82%. So in federated learning, performance becomes more balanced, and the model improves its ability to correct identifying the normal cases, importantly in medical diagnosis. You can see that for SVM it is 0.56 to normal cases 0.68, and for CNN also 0.55 to 0.68 due to the federated settings, and it also improves the accuracy. You can see SVM is 81.1%, and for CNN is 84.6%, and for LSTM it is 82.7%. And also we have reduced the false positive from 140 to 82, so which is 42%, and it is a better class balance across all these architectures. So we can directly compare this centralized and federated. You can see accuracy from 76 to 81, 76 to 84, 81 to 82. And with all this, CNN achieves the best accuracy, and in just 3 communication rounds. So this is a conversion analysis, how fast the model learns. So here the dotted line represents the centralized one.
Madam, please conclude your presentation.
Okay, sir. So this is a heat map of my. So from this study, we can derive some important insights, where splitting data across the clients helps balance classes naturally, and combining multiple models acts like ensemble, improves the regularization, overfitting is reduced, and most importantly, patient privacy is fully preserved. This is a clinical impact. So where we can uh, in federated SVM, we have reduced the false positives into 82, so it is 42% reduction. So we can, through this, we can achieve the unnecessary antibiotic treatment and increase patient anxiety, prolonged hospital stays are avoided. So FL produces a clinically safer and more equitable classifiers. So to conclude that federated learning is not just a privacy preserving technique, it actively improves its generalization through implicit regularization. So ready for deployment in the distributed hospital networks under HITAA and GDPR regulations. Thank you. Hello.
Yeah, thank you, madam, for your nice presentation.
Thank
So
you.
I don't have any question. Over to Monica, madam, if she has question, please.
No, I don't have any question.
Yeah, Alisha, we can go to the next presentation.
All right, yeah. So our last presentation for today will be by Sridharan Ji, who will be presenting an intelligent IoT and AI-based irrigation system for efficient water management in hilly agricultural area. Sridharan, you may now begin.
Thank you, ma'am. Good afternoon, everyone. I am G. Sridharan. Today, I present our work on AI-based smart irrigation system for hilly agricultural. And our project objective is to address a critical gap in agricultural technology where intelligent and terrain awareness irrigation solutions that combines IoT, hardware, cloud infrastructure, and AI reasoning to create a fully adaptive irrigation platform. The problem we occur in hilly agricultural are high water runoff, uneven terrain, and inefficient irrigation. The traditional methods which uses threshold values like conditional statements, which leads to nearly considerably 30 to 40% water loss and lack real-time adaptability. So our project objective is to develop a precise irrigation system which monitors real-time conditions and use AI for decision making and minimize the water usage. So the review of existing approaches are which is manual and timer based and threshold based values. So we proposed a system where ESP2 as a sensing layer and Superbase as cloud layer and Queen LLM model which is used for AI decision layer. This flow enabled us to monitor real-time values and irrigation control with intelligence. So the system works with a sensor, collect the data, and data will be sent to the cloud, and AI analyzes multiple parameters. So the conclusion will be the system which transforms the rule-based work into a AI-driven intelligent decision making by improving efficiency and sustainability in hilly agricultural. So these are the references. And thank you.
Okay, Sridharan.
Yes, sir.
Nice presentation with timely presentation, I can say. Just I want to know, it is a prototype, no?
Yes, sir.
Yeah, it is not yet tested.
Sir, can you come again?
Is it tested model or not non-tested model?
Sir, it is currently it is a testing model.
Can you show the testing some images and any kinds of data?
Sir, I currently have only web apps, sir, not prototype.
Okay, okay.
If
So
can,
over to
I
Dr.
can show
Bonisha.
you.
Yeah, over to Bonisha, madam. So if she has some question or not.
Okay, sir.
So, as I said earlier, please provide slide number. But I didn't understand what's your methodology. please explain. So, what is your objective and what is your methodology?
So
Please explain.
our objective is to monitor irrigation. Precise
Okay, that
irrigation.
I understood. But in terms of parameters, what you want to achieve and how you want to achieve that?
In parameters, we use soil moisture data and rain data, so that
You should
we
provide
can.
some flowchart or some methodology part you have to include.
Okay.
And when you provide literature, always provide the proper mentioning of authors with years. Go to second slide. Literature review slide.
What, ma'am?
Literature review slide, maybe the third slide.
Yeah.
This one. No. Before that.
Review of existing literature. Yeah.
So this is not the proper way to show research literature review. So please check that. So you are a master's student or undergraduate?
Undergraduate.
Okay. Okay, thank you.
So, about to Alicia.
Yes, sir. We'll now be moving on to the closing remarks. So I sincerely thank all of our authors for their excellent presentations and contributions to the session, and all our participants for being a part of this international conference. I hope the session was informative for everyone, and on behalf of the whole team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates via email within the next 2 working days, and the publication should be live in 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Before we conclude, I would like to present a token of our appreciation to the session chairs. So a big thank you to Dr. Banisha Bora and Dr. Hirakjyoti Hazarika. On behalf of the entire team ICTIS and Global Knowledge Research Foundation and partners, I thank you for your presence. Before we conclude today's session, I would like to request everyone to please turn on their cameras for a virtual snapshot. All right, everyone. Thank you so much. The session is adjourned.
Thank you, Alicia.
Thank you, Alicia. Thank you.
Thank you, everyone.
Thank you.
Thank you, ma'am.